KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Neet, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Right. In continuation to the last class, we start with impact parameter. Okay. So in our last class, we discussed what is helium nuclei, right? And after that, we focused to discuss Rutherford's alpha scattering experiment. Rutherford's alpha scattering experiment, and thereafter we discussed about the distance of closest approach, and there itself estimation of nuclear size. Estimation of nuclear size. Okay, right. I will repeat once again briefly last class information. What is meant by alpha particle means it is a helium ion, that is a helium atom from which both the electrons have been removed, right? And if you go to the charge of the alpha particle, which is equal to plus Ze, and mass is nearly 4 times the mass of proton. Thereafter, we discussed about alpha particle scattering experiment. There, based on that situation what we experienced according to Rutherford model or by the Rutherford, based on that scattering angle for different alpha particles, right, and thickness of the gold foil, that is what 2.1 into 10 to the power of minus 7 meter. We judge some of the valuable information, that is what the space occupied by the nucleus in an atom, and except this space, except the nucleus, what is present inside the atom. I mean, we concluded most of the space is empty. And thereafter, based on the scattering angle for different alpha particles, so where the most of the mass of the nucleus is concentrated. So this information we got from Rutherford's alpha scattering experiment. And next, number of scattered particles, capital N is directly proportional to 1 by 4th power of sine theta by 2. After that, the relation between number of alpha particles and thickness of the foil, n by t is equal to constant. From that we derived one relation which helps us while solving the problems. N1 by N2 is equal to T1 by T2. And after that, distance of closest approach R0 is equal to 4kZe square, 4kZe square divided by mv square, mv square. Okay. So from our previous class, our concentration, what is alpha particle and what is alpha particle scattering experiment, and then what is the expression for distance of closest approach, right? So these are the major things we discussed. Now in this class we start with impact parameter. Impact parameter, right? You can see this picture. So what is the atom, what is the nucleus, and what is the path of the alpha particle, and thereafter what is the central line of the nucleus. This is what central line of the nucleus, and the distance between these two, and the distance between these two is simply called as like B, that is impact parameter. impact parameter. See here, the perpendicular distance of the velocity vector, the perpendicular distance of the velocity vector v bar of the alpha particle from the center of the nucleus, the perpendicular distance of the velocity vector of the alpha particle from the center of the nucleus. This is what center of the nucleus. When it is far away from the nucleus, from the center of the nucleus, when it is far away from the nucleus, is known as impact parameter. Impact parameter, right? Suppose, for example, the situation what I am explaining for you, you just apply for the alpha particle when it is coming along this path. You know, in yesterday class I drew one picture. So from that picture, here for the alpha particle which is coming in this position will get 180 degrees deflection. No? When it is getting 180 degrees deflection, you know, what can we say? So the impact parameter will become like 0. No? That's why he mentioned one point here that we have to keep in mind when we are going to think about the impact parameter. That is what when it is far away from the nucleus, when it is far away from the nucleus. Okay. As simple as such, impact parameter is nothing but perpendicular distance between the velocity vector of the alpha particle from the center of the nucleus. Yes, this is what impact parameter. But there is a condition. What is that condition? When it is far away from the nucleus, when it is far away from the nucleus, is known as impact parameter. It is given as, so mathematical form, mathematical expression for impact parameter, small b is equal to z e square cot theta by 2 divided by 4 pi epsilon naught e k, 4 pi epsilon naught e k. E k is the kinetic energy of the incident alpha particle. E k is the kinetic energy of the incident alpha particle. And from this expression, I can also say that B is directly proportional to cot theta by 2. B is directly proportional to cot theta by 2. And from this, you just identify the situation, that is what for large B, alpha particle will go undeviated. For large B, alpha particle will go undeviated, and for small b, the alpha particle will suffer large scattering. Once you just recapped the yesterday picture what I drew in the Neet class, there you just take one of the alpha particle which is going here almost, this is also not at the ending, right? Still something is there, right? That's why what I am saying is, you just take two alpha particle which is going almost here and another one is going here, right? Here we can experience or we can expect less amount of scattering, less amount of angle of scattering, and here you can expect more amount of that is what scattering angle. So that only he is saying here. For large B, alpha particle will go undeviated, and for small b, the alpha particle will suffer large scattering. Large scattering. Right. Next, Rutherford's atom model. Rutherford's atom model. See here. First he is going to explain about Rutherford's atom model, and then he will explain drawbacks of Rutherford model, and then he will explain Bohr model, and after completion of that, we will go to discuss drawbacks of Bohr's atom model. Okay, we will start with Rutherford's atom model. Listen carefully, every line is important, every word is important here. The whole positive charge of atom, the whole positive charge of atom is concentrated in its nucleus, which is of very small size as compared to the size of atom, as compared to size of atom, full stop. Atom has a size of the order of 10 to the power of minus 10 meters, whereas nucleus has a size of the order of 10 to the power of minus 15 meters. Please try to understand, he is talking about the nucleus as well as about an atom. So here he is comparing the size of the atom and size of the nucleus. And he is also talking about positive charge, whole positive charge present in an atom. So what he is saying here, the whole positive charge of atom is concentrated in its nucleus, which is, so nucleus, which is of very small size, which is of very small size as compared to size of atom, which is very small size as compared to size of atom, full stop. Atom has a size of the order of 10 to the power of minus 10 meters. Atom has a size of the order of 10 to the power of minus 10 meters, whereas nucleus has a size of the order of 10 to the power of minus 15 meters. You just compare, what is the size of the atom? 10 to the power of minus 10 meters. What is the size of the nucleus? 10 to the power of minus 15 meters. So based on these two numerical values, we can imagine what is the difference in size regarding the atom and nucleus. Though the nucleus is present inside the atom, we need to compare the size of the nucleus to the size of the atom. So the size of the nucleus is very small when compared to the size of atom. Here we have to remember one small conversion, that is what 1 Fermi is equal to 10 to the power of minus 15 meters. Next, see here, electrons are situated in the large empty space. Electrons are situated in the large empty space around the nucleus and are revolving such that the centripetal force is provided by the electrostatic force of attraction. The centripetal force provided by the electrostatic force of attraction between electrons and nucleus. Between electrons and nucleus. Okay. What I am saying is here, see this, electrons are situated in the large empty space around the nucleus and are revolving such that the centripetal force, right? The centripetal force is provided by the electrostatic force of attraction between electrons and nucleus. Between electrons and nucleus. See here, I am saying electrons are situated in the large empty space around the nucleus. So there is a difference in the size of the nucleus and size of the atom. So except the space occupied by the nucleus, what about the remaining space in an atom, right? In that remaining space, the electrons are present. Electrons are present. Electrons are situated. Electrons are situated. And these electrons are revolving. And these electrons are revolving such that, see here, listen carefully what I am saying, such that the centripetal force is provided by the electrostatic force of attraction between the electrons and the nucleus. What is centripetal force? the basic force which is required for an object or for a particle or for a body to be in circular motion. So when the electrons are revolving in circular motion, the required centripetal force, no, right? When the required centripetal force, so who will provide the centripetal force for the electrons to revolve around the nucleus? So here, electrostatic force of attraction. Electrostatic force of attraction. And how to calculate the electrostatic force of attraction? From the first chapter, electrostatics, Coulomb's law, Coulomb's inverse square law. Okay, and centripetal force also F is equal to mv square by r. Okay, so for the electrons to revolve around the nucleus, the centripetal force is provided by the electrostatic force of attraction between electrons and nucleus. Between electrons and nucleus. Next point. The atom is neutral overall. The atom is electrically. The atom is neutral overall. So, the total positive charge on a nucleus. So, the total positive charge on a nucleus is equal to the total negative charge on electrons. Right? Total negative charge on electrons. So, this is the reason. So, first he has given information, that is what atom is electrically neutral or atom is neutral overall, but why it is neutral, or why it is neutral means the total positive charge on nucleus is equal to the total negative charge on electrons. So, finally what is the charge? Is it 0? No. Right? When it is 0, you can say that atom is neutral overall. Next, drawbacks of Rutherford's model. Next one is, so just now we discussed the important points from Rutherford's atom model. Now we are going to discuss the drawbacks of Rutherford's model. See here, Rutherford's atomic model is inconsistent. Rutherford's atomic model is inconsistent with classical physics according to electromagnetic theory. According to Rutherford's atomic model is inconsistent with classical physics. Okay, right. According to electromagnetic theory, an electron is a charged particle. An electron is a charged particle moving in the circular orbit around the nucleus and has an accelerated motion. So, it should emit radiation continuously and thereby lose energy. So, please try to understand. Rutherford's atomic model is inconsistent with classical physics. Okay, right. This is the important point. According to EM theory, electromagnetic theory, according to electromagnetic theory, an electron is a charged particle moving in the circular orbit around the nucleus and has an accelerated motion. So, it should emit radiation continuously. So, it should emit radiation continuously and thereby lose energy. Lose energy. Okay, right. Thereafter, what would happen actually? Due to this, radius of the electron would decrease continuously. Radius of the electron would decrease continuously. Spectrum, and ultimately electron will fall into the nucleus. When electron will fall into the nucleus, you can say that the atom will collapse in 10 to the power of minus 8 seconds. The atom will collapse in 10 to the power of minus 8 seconds. Full stop. But the atom is fairly stable and it emits line spectrum. Okay, right. So, please try to understand the point, because which is very important point from drawbacks of Rutherford. The Bohr model, the next what we are going to discuss, the Bohr model will tell and will overcome this drawback. So, you please try to understand the drawback of Rutherford's model. It's okay. That is what Rutherford's atomic model is inconsistent with classical physics, right? So according to electromagnetic theory, what should happen? According to electromagnetic theory, an electron is a charged particle moving in the circular orbit around the nucleus and has an accelerated motion. So it should emit radiation continuously and thereby lose energy. So when the electron is going to lose energy due to the accelerated motion around the nucleus, it has to fall towards the nucleus. When it is going to fall, when it will fall towards the nucleus or into the nucleus, atom has to collapse in 10 to the power of minus 8 seconds. But in practical, the atom is not collapsing. That is what the atom is fairly stable and it emits line spectrum. So what can we say here? So this is the thing what happens. But according to that, it has to be happen in reverse mode. But it is not happening. So that's why we are saying that this is the drawback of Rutherford's model. So according to the Rutherford's model, the atom has to collapse in 10 to the power of minus 8 seconds. But it is not happening in practical. That's why we are saying that this is the drawback. This is the drawback of Rutherford's atomic model. Next, it didn't explain the distribution of electrons outside the nucleus. It didn't explain the distribution of electrons outside the nucleus. For example, you just imagine 10 electrons are there outside the nucleus. So how the electrons are distributed, right? So 10 number of electrons are close to the nucleus or far away from the nucleus, and that situation of distribution of electrons outside the nucleus not explained by Rutherford model. Next, see here, Bohr model. See this. Here we have 2 points, but not only 2 points, there are more. There are nearly 5 points. But in this class, we will discuss 2 points. Next, we will discuss in the next continuation class. See here, Bohr model. The atom consists of central nucleus containing the entire positive charge and almost all the mass of the atom. I will repeat once again. The atom consists of central nucleus containing the entire positive charge and almost all the mass of the atom, full stop. The electron revolve around the nucleus in certain discrete circular orbits. The electron revolve around the nucleus in certain discrete circular orbits. Discrete circular orbits, full stop. The necessary centripetal force for circular orbits is provided by the Coulomb attraction between the electron and the nucleus. So what he is saying in the first point of Bohr model, what Bohr is saying, an atom, okay, the atom consists of central nucleus containing the entire positive charge and almost all the mass of the atom. The electron revolve around the nucleus in certain discrete circular orbits. The necessary centripetal force for circular orbits is provided by the Coulomb attraction between the electron and nucleus. So here, what is the information we are getting? The first thing is, right, atom consists of central nucleus which containing entire positive charge and almost all the mass of the atom, right? And the electron is revolving around the nucleus in certain discrete circular orbits. So the necessary centripetal force, because I told you already just before 5 minutes in the same class, for a body or an object or for a particle to be in circular motion, it needs centripetal force. The primary and fundamental force it requires is centripetal force. So according to Bohr also, centripetal force is provided for the electron by the Coulomb attraction between the electron and the nucleus. Between the electron and the nucleus. Next point. See here. The allowed orbits for the electrons are those in which the electron doesn't radiate energy. So it doesn't radiate energy means it doesn't absorb energy, it doesn't release energy. So the allowed orbits for the electrons are those in which the electron does not radiate energy. These orbits are also called as stationary orbits. These orbits are also called as stationary orbits. These orbits are also called as stationary orbits. Okay, right. So according to Bohr model we have 5 points, but here we discussed only 2 points. Remaining points we will discuss in the next class. Okay, right. So in this class we concentrated on impact parameter. Afterwards Rutherford's atom model. In Rutherford's atom model we discussed the positive points, I mean the core information what we are getting practically valid from Rutherford's atom model, and then we discussed the drawbacks of Rutherford model. Thereafter we discussed what is a Bohr model and the important information from Bohr model, but we are in continuation with the Bohr model. In the next class we will continue to discuss. Okay, thank you.